normally when you log into a Cisco iOS device with SSH, you're logging in with a username, and then you're sending along a password. If you're secure, you're doing it with SSH. You're not using Telnet, right? Of course you're not. I know some of you are. Don't stop that. If you're on SSH, you're using a password. The whole connection is ciphered. The authentication process is ciphered and encrypted, etc. So nothing's going over the wire in clear text like it would be with Telnet. So one other way you can authenticate to a Cisco iOS device with SSH is using public-private key pairs. That is, you generate a public-private key pair, and then you give the devices you wish to authenticate to you the public key. You keep the private key and use that as the other half of your authentication. You are also going to assign a passphrase to your private key so that no one else can use it were your private key to be stolen. So let's walk through this, and we'll talk through some of the implications of this whole process as we do it. So, all right, so I am on my Mac, and the first thing I need to do here is actually generate a public-private key pair. So I've got a command here that's going to do that for me. This will work on Linux, this will work on Mac. Windows, I'm not sure what the process is. I didn't research it for the purposes of this lab. I'm sure it's doable, but here we go, SSH keygen, and then I'm going to generate an RSA key. 4096 for the modulus, and then I'm going to use a user of ethernetlab.cogevent.com, Cogevent being my consulting company, which is a convenient domain name to use. So if I hit enter, generating a public-private RSA key pair. Enter the file which to save the key. This is the default setting, so on a Linux-based system, which Mac isn't part if you knew about it historically. So this is in my home directory, .sh/id_RSA. That's going to be my private key. I already generated one. I'm generating another one for purposes of this lab. So yeah, I'm going to overwrite it. That's okay. Enter a passphrase, empty, for no passphrase. Okay, this is an important deal here, this issue right here. When you authenticate with a public-private key pair, the public key is freely distributable. You can send that out to the world and need to. You need to distribute that public key to any hosts that you want to use your public-private key pair to perform authentication with. That's fine. It's just a plain text file. And you don't need a passphrase on that. The public key is the one you can send out the door. But this is our private key, the first one that we're generating in this key pair here. And if we don't put a passphrase on it, here's the problem. Let's say someone steals your private key, this ID_RSA. It's just a file. If they steal it, they can then use it to authenticate to any device that has that public key. It would be just like they stole your password. But if I put a passphrase on, as is being asked of me, then I would not only need to steal the private key file, I would also need to know the passphrase to that file in order for it to be useful to me. So do I want to have a passphrase? Yes, I do want to have a passphrase here. And I would treat this like a password. I'm just using something very simple here. The word pass for passphrase, not very secure in this case. So let's look at what we've done here. So I've generated the passphrase, and then I've got a couple of important lines reported back to me. Your identification has been saved in, your public key has been saved in. Okay, so my identification, my private key, there it is. ID_RSA saved in my home directory underneath the .ssh folder, and it is called ID_RSA. My public key, again, in my home directory in the .ssh folder, and it is named ID_RSA.pub. Again, ID_RSA, that's my private key and the one that I'm concerned about keeping. Now, the purpose of this exercise today is to show us how we are going to set up a Cisco iOS device to use this public-private key pair that I have just created. So let's take a look at a router that I've got configured. I'm using my, a lot of you would, this is my console software. This is called MTech. Our company is MTech, and the product is ZOC, Z-O-C. I've been using it for about 10 years. It's not free. I don't know what the current pricing is, honestly, but here we go. So I've logged into a iOS device that's in my lab using a traditional SSH username and password. So if I look at my configuration here, how to log into this device, I've got a username configured and I've got a password configured. And I'm just logging into this router, the IP address of this router that I've got in my lab. So it's just, if you're used to PuTTY, it's just a different interface that you're looking at as far as configuring the host. But there's nothing magical that's going on here. I'm just logging into this router and then logging in with a username and a password. That's all that happened to make that go. And here I am. I'm logged in. I got my banner message of the day. I say enable. And if I do a show run, I'm going to include SSH and just kind of show you what we've got here for an SSH server configuration. Nothing especially exotic. I set up a timeout. I set authentication retries up at 5. I turned on event logging. I'm using version 2. And then these two lines are actually from the line VTY paragraphs at the bottom. I'll show those to you. So other than having manually generated the key that you need to generate on an iOS device to crank up the SSH server, I haven't done anything magical here on this box. So let's look at the username configuration. I've got a user called Ethan with a password that is unstored, unciphered, which you'd never do this in a production environment. This is a lab, and it's just easier to show you what's going on here. I've got a password on this account of packet pushers. All right, what's the AAA configuration? AAA, authentication, authorization, and accounting. I've just done a very simple that new model command to let this device know it's got a AAA configuration, kind of kicks things off, and then I've said AAA authentication. My login default method is going to be local. Again, I wouldn't really do this in production. I'd probably be logging into a TACACS server and using, my typical configuration has been to use local as a fallback. If my TACACS or Radius server, like an ACS box or an ICE box, is not available, then I would fall back to local so that I can still get into a box even if it's isolated from the network, let's say. Got some kind of problem with the routing in your world that day and you can't get to that device, okay, then you fall back to local. In this case, because it's lab, I've just got it. I'm using the local user database, and the only user I've actually got configured is this Ethan account. All of that just a baseline and show you what the iOS SSH and authentication scheme is on this lab router that I've built to show us how to do public-private key pairs. So the next step that I need to take is to tell this iOS device, hey, you're using a password scheme right now, username Ethan password. I want you to use a public-private key pair for that account. So how do I do that? Well, we're going to enter into configuration mode. I've actually saved off the config off to the side here. This is the big command I need here. IPSSH pub key chain. And that's all I can do is type that in. So I'm basically telling the SSH server, hey, you're about to get a public key from me. And now what other things can I put in here? Well, I could put in server side, user side, or I can get out of this whole configuration subparagraph. I am dealing with my user, right? This Ethan account that I've built. And then as you'd think, it just wants me to put in the username. And now, what are my choices? I can put in a key hash, or I can put in a key string. What I've got is the key string, and that key string is the public key that I generated when we started this whole thing. That is this file right here. I'm in my user directory right now. That's what the squiggle here means. So if I change directory to .ssh, there's my private key, and here's my public key. The public key is the one we're trying to get into the iOS box at this point. Let's list this thing out. Okay, there it is. I got to get that big, long, ugly mess into here. So again, I'm going to highlight this, Control C, because we're copying. This isn't going to work, okay? Well, I know that this isn't going to work because this string is too long, but I'll show you anyway. If I paste this in, it gets as far as it can go, and then it's like, it's just out of input buffer. It can't handle any more characters. So if I hit enter on this, it chokes at me. Oh, you know what? Well, this is still going to fail, but I got one more step to take. I never did tell it if we were doing a key string or a key hash, so I need to tell it key string. All right, let's paste that again, my public key, and like I said, it is going to choke. It'll choke for a different reason this time. Again, it gets as far as it can, runs out of input buffer. I hit enter, and it is going to. It's going to complain at me. I swear it is. It's going to tell me that that's not a good string. Because it can't compute the hash. Oh, there we go. Okay, that's what I was looking for. Failed to decode the key value. In other words, I looked at that mess you typed in, and guess what? It ain't a key. I did the math. There's nothing. There's nothing here. I don't know what I'm supposed to do with this. Try again, pal. All right, so let's try it again. If I say key string, what I can do is paste it in chunks. So how long of a chunk? I'd have to look up and see exactly what the input buffer is. I don't remember. So let's go, let's see if it can take 2 of my lines at a time here. Got to HX, got to HX, that's good, all right. So let's keep pasting, I'm gonna keep pasting. Copy, paste, putting in more of the public key here. And if this seems clunky to you, it is a little bit clunky. I mean, what you could do is just take all this and put it into a text editor and then send up the lines, line by line that way. And then you'd have a way to deal with it from a sort of a script file that you created in your text document. All right, so there it is. I was able to paste it all in. Let me type exit, and no complaints. So let me exit out. So let's see what we got here. What have I created? And what we're going to see is that iOS took that value and is now storing it, that public key value, and is now storing it as a hash. So here it is. That's everything we just input. And here is the hashed value that was unable to be computed the first time when we tried to just dump the whole thing in and then say go, and it didn't go because we never did get the whole thing in on that initial paste. So that's why we went back to the 2 lines at a time thing to get it all in there. All right, so there's my config. So now I have a public key. It is associated with the username. Let's take a look at my a login attempt here, a login configuration from my console server, and see if we can get this thing working. So it's the same host. I gave it a different name just so I could distinguish password method versus public-private key exchange method. Going to connect to the same IP address. Log in. The password field is blank, and I have pointed the console, my terminal server software here, to my private key, right? That is my private key. That's my public key, and that's my private key, and it's living in that same folder. So I've got the right thing here. The iOS device has my public key. I'm using my private key on my side. Now, this is another thing to understand here. All that these public-private keys are for in this case is authentication. This is not going to be used for actual communications once the authentication phase is over, and now we're just chatting. We're past the username and who are you thing. Then these keys are no longer used. This is all we're doing is a different way of authenticating. We are not doing changing the way the SSH cipher is done. By default, SSH uses symmetric keys, and those are figured out between the two endpoints when the session is established. What we're doing here is just changing the authentication means using asymmetric keys, a public and a private key. So we're all set up. Let's give this a shot. Firing up a new session. I think I've done everything I need to do. Right, I'm being prompted for my passphrase. Remember, the passphrase was generated for the private key by me. I was prompted by the SSH keygen process on my Mac whether or not I was asked, hey, do you want to put a passphrase on this private key? And we said, yeah, we want to do that. In case our private key gets stolen, it's still useless unless you know the passphrase. Now, my passphrase was something very simple. Ordinarily, you protect it with something appropriately complex. And my passphrase was just the word pass. And look at that, I'm logged in. So now here's a question. Can I still log in using my password? I don't think I've tried this before. It's actually an interesting question. I know I just proved I could do it with public-private key. Can I actually still log in with my password? So I've got password configured. Looks like I can. So let's have some fun here. What happens if I remove that line completely, if I just say no username? I kind of assume they were associated objects in iOS, that the IPSSH pub key chain associated to that username would be tied to this line. Maybe they're not. Maybe they're effectively two different accounts. So let's prove this here. What happens if I do no username Ethan? All username-related configurations with the same name. Do you want to configure? Do you want to continue? Confirm. So if I do this, what it's telling me, what I think it's telling me is it's going to blow away my public key config as well. So let's find out. If I do that, oops. Include username, do I still have a public-private key config left? Ooh. Thinks I do. I thought that would actually be gone based on that. This warning sounded like, you sure you want to do this? I'm going to kill everything. You got me? And I was like okay. So who's going to take out the SSH public key config as well? But it doesn't seem to have. I can find that paragraph here, see what it tells us. Oh, okay, here it is up at the top. I still got that username, and I've still got my key hash and my RSA. So now password should not work, right? Because I just deleted that username. So that should definitely not work. So let's try it again. This should just break, right? Please break. Permission denied. So that doesn't work. And if I make let's clone session here. So I'm going to make another authentication temp with public-private key. Here we go. Asked for my passphrase for my private key. Pass, okay. Thinking, and I'm in. There we go.